Welcome back to the Deep Dive. Today we're diving into how SpaceX is using AI to make space travel more like something out of a sci-fi movie. Like it's straight out of Star Wars, but it's real. We're talking Mechazilla, Falcon, reusable rockets, the whole shebang.
It really is incredible what they're doing, pushing those boundaries.
It is. So let's break it down a bit. For those who might not be familiar, what exactly are we talking about when we say Falcon and Mechazilla? Those are some pretty cool names.
Right. When we say Falcon, we're talking about SpaceX's Falcon 9 rocket. And
Ah.
the really cool thing about Falcon 9 is that it's designed to be reusable.
Ah, okay, so that's different from the old days when they would, just use a rocket once and that was it.
Exactly, pretty much. Before SpaceX, rockets were basically single use. Crazy expensive and wasteful, too.
Yeah, I can imagine. I mean, sending anything into space can't be cheap.
Yeah.
So how does this whole reusable thing make it more affordable?
It's all about not treating rockets like disposable things. SpaceX engineered the Falcon 9 to come back to Earth and actually land vertically.
Whoa, vertically? That's insane.
Yeah, and that's where Mechazilla comes in.
Okay, now you have to explain this. That sounds like a monster movie or something.
Right, it sounds like it should be destroying a city, but it's actually this massive robotic arm system, and it's designed to catch those Falcon boosters as they come back down.
No way. So they literally catch a rocket falling from space.
They catch a rocket falling from space.
That just seems, I don't even know, incredibly difficult. What's the toughest part about that, making that catch?
The precision needed is just mind-blowing. Think about it. A rocket the size of a skyscraper falling from space at supersonic speed, and you have to catch it gently with these giant robot arms.
I can't even imagine the calculations involved in that.
It's really incredible. And to make it all work, they're relying on some seriously advanced tech, artificial intelligence being a big one. AI is a huge part of why this is even possible.
Okay, so let's talk AI then, because that's what really fascinates me about all this. Where does it come? Like even before they launch, right?
Yeah, AI is involved at every step. I mean, even before liftoff, it's running thousands of simulations, analyzing everything. Wind, drag, even tiny manufacturing differences on the rocket to make sure everything goes perfectly and they can actually make the catch.
They're running simulations of the catch too, like practicing in a computer before they do it for real.
Exactly. They have these things called digital twins, basically virtual models of Mechazilla and the booster, and they practice the whole catch in a virtual world.
That's wild. So they know, like, if the wind's blowing a certain way, how the rocket might move.
Exactly. They try to account for everything they can.
Wow. Okay, so the AI does its thing pre-launch. The rocket goes up.
Mhm.
What's AI doing while the Falcon 9 is in the air?
Okay, so get this. While the rocket's in flight, AI basically becomes this ultimate multitasker.
Oh man, I can relate to that. What's it doing?
It's using GPS, sensors, even star tracking to know exactly where that rocket is every millisecond.
It's like a super precise GPS, but instead of telling you how to get to the grocery store, it's keeping a rocket from, crashing back to Earth.
Exactly. And it's not just tracking. It's actively adjusting the rocket's flight path based on real-time conditions.
So if there's a sudden gust of wind or something, the AI can compensate and keep everything on track for the catch.
Precisely. Without AI, they wouldn't be able to pull this off.
So the AI is basically like the world's most intense air traffic controller, but for rockets.
That's a great way to put it. But things get even more interesting as the booster starts heading back to Earth for the catch.
Oh, I bet. Because even with all that AI prep, I'm guessing things don't always go perfectly smoothly, right?
You'd be surprised. It's incredibly precise, but of course they plan for contingencies.
Like what kind of backup do they have if something unexpected happens during the catch?
Well, for starters, they've got multiple AI systems running simultaneously. So if one encounters an issue, there's a backup ready to take over instantaneously.
Okay, so redundancy is key here.
Exactly. It's mission critical, right? They can't just hit a reset button when you've got a rocket falling out of the sky.
Not unless you want to test out how strong those robot arms really are.
Yeah, not the ideal situation. But AI is doing even more. As the booster descends, it's using a bunch of cameras on both Mechazilla and the rocket, and it's analyzing those video feeds in real time to make sure everything lines up perfectly for the catch.
It's like those claw machine games at the arcade, but a million times more complex and with much higher stakes.
And way cooler prizes, too.
That's true. So let's say after all that, the catch is successful. Everyone's cheering back at mission control, but AI's job isn't over yet, right?
Yep, not even close. This is where the real learning begins.
Oh, tell me more.
After the catch, the AI dives deep into all the data from the flight. It's like it goes back and analyzes everything to see how it can do even better next time.
So the AI is constantly learning and improving, just like a human would.
Exactly. Every flight gives it more data, and it uses that data to refine its approach and make each subsequent mission even smoother, even more efficient.
That's incredible. So it's not just about making reusable rockets. It's about using AI to constantly push the boundaries of what's possible.
Absolutely. And the really amazing part is how this impacts the cost of space travel.
Right. Because we were talking about how expensive it used to be.
It was astronomically expensive,
Like launching a loaf of bread into orbit would cost you a small fortune.
more like a small island.
Yeah.
But with these reusable rockets and the AI making it all work, SpaceX has drastically reduced the cost of launching things into space.
Drastically. How much are we talking here?
Like 90% or more.
90%. That's insane. Okay, so what does that kind of cost reduction actually mean for, the future of space exploration?
It's a total game changer. I mean, think about it. Cheaper launches mean more opportunities for research, more ambitious missions, maybe even space tourism becoming a real possibility. This is opening up space for everyone, not just governments and billionaires.
It's like we're moving from the era of horse-drawn carriages to the jet age, but for space travel. So what are some specific things we might see happen because of this? Like what kind of scientific advancements are we talking about?
Well, for one, we can send bigger, more powerful telescopes into space.
Which means we can see even further into the universe, maybe even unlock some of those big mysteries about how it all began.
Exactly. And it's not just telescopes. Imagine being able to study other planets in more detail, maybe even send missions to search for signs of life beyond
Okay,
Earth.
no, that's what I'm talking about.
And because we can launch more frequently, we can respond to things quicker. Like, say, an asteroid is heading towards Earth.
Okay, that got serious fast.
But it's a real concern. But now, with reusable rockets, we could potentially launch a mission to deflect it much faster than before.
It's like something out of a movie, except this is real life.
Yeah.
It's incredible to think about all this becoming possible because of AI.
And the crazy thing is, we're just scratching the surface of what AI can do. I mean, right now, it's assisting with all these tasks, but what about fully autonomous spaceflight?
Whoa, hold on, autonomous spaceflight.
Oh, great.
Like no pilots, no astronauts, just AI running the show.
Exactly. AI handling everything.
Right.
Navigation, docking, even scientific experiments, all without us having to lift a finger.
So are we talking like AI-controlled robot explorers going to other planets? That's some next-level stuff.
Yeah.
But what does that mean for us humans? Will we just be watching from down here while the robots do all the cool stuff in space?
Not at all. Human curiosity, our drive to explore, that's not going away.
Yeah.
AI just frees us up to focus on the really interesting stuff, the big questions, the scientific discoveries.
So it's more like a partnership, AI handling the technical stuff, and humans doing what we do best, exploring the unknown.
Exactly. It's like having a super smart co-pilot that never gets tired and can do all the complex calculations.
Okay, that's actually a really cool way to think about it. And this future, with AI and space exploration working together, how far off do you think it is? Are we talking like Star Trek timelines here, or is this something that could happen sooner?
Honestly, it could be a lot sooner than people think. With the progress SpaceX is making and with AI technology advancing so rapidly, we could see some really amazing things in the next decade or two.
Wow, that's incredible. It feels like we're on the verge of a whole new era of space exploration, all thanks to this amazing combination of human ingenuity and, let's be honest, some really cool AI.
It's an exciting time to be following space exploration, that's for sure.
It really is. So to wrap things up, what's the one big takeaway you hope listeners will remember from this deep dive?
I think it's that the future of space exploration isn't just about rockets and technology. It's about pushing the boundaries of what's possible, and AI is going to play a huge role in that.
Beautifully said. It's about daring to dream big and realizing that the sky is definitely not the limit when it comes to exploring the universe. This has been an awesome deep dive. Thanks for joining us as we explored Mechazilla, Falcon 9, and the incredible world of AI in space. Until next time, keep looking up, keep asking questions, and never stop exploring.